Hi, Mr. Metters here. I want to talk about subnetting. And what I want to do is talk about subnetting. Um, we're going to do a Class C address, and we're going to borrow 2 bits and see what happens. Okay. Now, remember, this is our subnet table right here, where we have 128, 192, 224, etc. up here. What you notice is, remember, the top row is my subnet mask for the octet that I'm going into, and the bottom row is my range increment. Okay. So new subnet mask right up here. All right, so let me undo that. Okay, new subnet mask is on the top and range increments down below. Now let's take a little problem, and we're going to borrow just 2 bits and see what will happen on a Class C. We got the address is going to be, the network number is 202.50.60.0, with the default mask of 255.255.255.0. Or if you put it in /x notation, that's classless notation, you count the number of bits in each octet in the mask, and 2558 represents 8 bits. So 8 times 3 is 24. Okay? So let's go ahead and subnet this. We want to borrow 2 bits. When we borrow 2 bits, what's going to happen is we're going to find that we're in this little area . Hang on a second. But that is our column that we need. Remember, top number is a subnet mask, and the bottom number is the range increment. So what we're going to do is start with our little table. Now, I'm going to only do the last octet, which is this one right here, the .0 octet. So it's going to be, we start with 0.0. We add the range increment of 64 until we get to the top number. Okay, this is my net number. This is going to be my low and my high. The high is the highest address I can assign on that row. So for the low, you add 1 to the network number. For the broadcast, it's going to be the next network number minus 1. Okay? So 64 is the next network number, minus 1 is 63. All right. Dot 65. Whoops. Now, the high is dot 63, the broadcast, minus 1. Okay, we'll re-summarize this in a minute. So it's going to be dot 126. All we're doing is counting for all the numbers from 0 to 255. 127. And this is going to be a dot 129. And yes, I see the mistake down and below, dot 19. This is going to be dot 190, dot 191, 92, dot 193, dot 254, dot 255. Okay? So let's do a little recap over here. The network number, here's the process. To get the network number, I do the network number column first. You will start with the 0.0, increment, that means change by, the bottom number up here. Of the column you circle, increment by the RI until you get to the subnet mask, or the top row. So you start with 0, increment by 32 until I get to the top number, and you can clearly see I've done that right down here. Okay, the difference between each of these rows for all the columns, it should be 64. Okay, that's the network number. I'll do the network number column first. Okay, now the next thing I want to do is I would do I'd do the broadcast first. The broadcast is going to be equal to the next net number minus 1. The low is going to be equal to the next network number plus 1. The high is equal to the broadcast minus 1. And that pretty much sums up how you do this. Now, what's the subnet mask? The new subnet mask is .192. Okay? It's going to be the range increment number down here. Okay? I'm sorry, not the range increment. Subnet mask is right there. So what I'm going to do is I'm going to go ahead and close this out. Thank you very much. This is what the table would look like when you borrow just 2 bits. Notice one other thing over here. You've got 6 bits left over. 2 to the 6 is 32. I'm sorry, 64. And 64 minus 2 is 62. The difference between the low and the high here is 62. In other words, the low and the high, the lowest IP address you can assign on that row is .1 for the first network, and up to .62, which is 2 to the 6 minus 2 is 64 minus 2 is 62. In other words, the difference between the low and the high, including the low, is 62. All right, you got 62 items you can actually computers you can actually assign IP addresses. For the 64 network, it's going to be .65 through 126. It's because of the bits workout. I borrowed 2 for the network. If I borrow 2 bits, 2 squared is 4, and here's my 4 networks right down here. It's 4 rows. But if I have borrowed 2, which gives me 4 combinations, 2 squared is 4, then I got 6 left over, because remember, each of these occupy 8 bits. So 2 to the 6 is 64, minus 2 is 62, and so I get 62 network or computers and hosts that I can assign IP addresses. So I got started with 8 bits, and then when I borrow 2, I got only 6 left over. If I borrowed 3, I'd have 5 left over. Okay. Thank you very much. Copyright 2008, Mr. Todd Metters. Thank you.